Next question, you have to prove that a function is given from natural numbers to natural numbers and it is defined by f of x, x square plus x plus 1. We have to prove that it is 1, 1 but not onto. Okay, so to prove 1, 1, you have to take two elements from the domain set. Okay, so let's say x1, x2 belongs to set of natural numbers. And we are starting from f of x1 equal to f of x2 and we'll show that x1 is equal to x2. Okay, so f of x1 is x1 square plus x1 plus 1, x2 square plus x2 plus 1. So this gets cancelled. If you take this x2 square and x2 this side, you'll get x1 square minus x2 square plus x1 minus x2 equal to 0. Okay, this you can use here a square minus b square. So a minus b, a plus b plus x1 minus x2 equal to 0. So you can take common x1 minus x2. Okay, so this is okay. So either this term is equal to 0 or this term is equal to 0. So if you take this term equal to 0, you will get x1 equal to x2. Now if you take the second term x1 plus x2 plus 1 equal to 0, okay, this is not possible. Reason? Because x1 and x2 both are natural numbers, correct? If both are natural numbers, then both are positive. So there is no way these numbers can become negative so that they get cancelled with 1. Okay, and there is no 0 also. So this is not possible. So we have to go with this condition. So this shows that this function is 1, 1. Okay, let's solve for onto. We have to prove that it is not onto. So you have to take some element from the range set, okay, codomain, such that there exists x belonging to n such that y is equal to f of x. Okay, so y is equal to x square plus x plus 1. So we have to find x now. So you can take this y this side. So you'll get one quadratic equation. Okay, using the discriminant method, that is this quadratic formula method, you will get this answer as x equal to minus b. B here is 1 plus or minus root of b square minus 4 into a into c upon 2a. Okay, so this is 1 minus 4 plus 4y. So we'll get minus 1 plus or minus root of 4y minus 3 upon 2. Now you have to check for the numbers. Okay, so if you get a negative number, then this is not possible, right? Because x should be positive because x belongs to set of natural numbers. So if I take y equal to, say, if it is 4 ones are 4, then it will be a positive number. If it is y is 2, if I take, say, y equal to 2, then I'll get this as minus 1 plus or minus root of 8 minus, okay, this is, okay, 4 to the 8, 5 upon 2, okay, so minus 1 plus root 5 upon 2 or we get -1 minus root 5 upon 2. This case is already eliminated because both are negative, so the number is negative. Okay, what about this? So you have to look for the root 5. So this root 5 falls in between root 9 and root 4. This is of no need. Okay, x should be a natural number. If you take a number which is under root, okay, this is not a natural number. This does not belong to a natural number. So this already proves that this is not onto. Okay, this much is enough actually. If you have y is equal to 2, okay, if you take y is equal to 1, then you will get this as -1 plus or minus root of 1, right? Upon 2. Root of 1 we can write 1. We will get some number. Okay. But if you take this 2, y equal to 2, then we get a number which is under root. And under root numbers are, this number is irrational. Okay. This is not a natural number. So our x does not belongs to natural number. So we say that for a y equal to 2, there does not exist a number in our domain. So this is not onto. Okay. Next question. Function is defined from q difference 3 to q. Q is a set of rational numbers. Okay. And here the number 3 is removed. Okay. Defined as f of x equal to 2x plus 3 upon x minus 3. Why 3 is removed? Because if 3 is not removed, then this function becomes not defined. That is, we will get here upon 0. Okay. Is f surjective? Surjective means we have to check for onto. Okay. And also for 1, 1. Let's start. So to check for surjectivity, you have to take an element from the range set. Correct? So let's say y belongs to q. So there exists some x belonging to q difference 3 such that y is equal to fx. Okay. So y equal to 2x plus 3 upon x minus 3. Now we have to find the value of x in terms of y. So this is xy minus 3y, 2x plus 3. Okay. At 2x you have to take this side, 3 plus 3y. So this is y minus 2. So x is equal to 3 plus 3y upon y minus 2. Okay. So if you take this x, okay, this is from the domain set, okay, where 3 is removed. And when you have y equal to 2, okay, y equal to 2, then this x becomes not defined. That is, when you substitute here y equal to 2, you will get here 0. So it is not defined, right? So for y equal to 2, there does not exist x belonging to q difference 3. Okay. So we say that this does not belong to q difference 3. Okay. For this value, there is no pre-image. Okay. So we can say that it is not surjective. Okay. Now you have to check for injectivity. That is 1, 1. So you have to start with two elements from the domain set. So let's say f of x1 is equal to f of x2. So 2x1 plus 3 upon x1 minus 3, 2x2 plus 3 upon x2 minus 3. Okay, cross multiplying will get 2x1 plus 3, x2 minus 3, 2x2 plus 3, x1 minus 3. Okay, so multiplying this will get 2x1, x2, 6x1, 3x2, 9, 2x1, x2, 6x2, x1 minus 9. Okay, so whatever you can cancel, you can cancel. So this is 3 you can take common. 3x2 minus 3x1 minus 6x1 plus 6x2. This gets added up, right? Minus 6x1 minus 3x1 is minus 9x1 equal to minus 6x2 minus 3x2 minus 9x2. So x1 is equal to x2. Okay, so this is one. Let's solve this. So here relation set is defined as a set of a comma b such that a is less than or equal to b square. Okay, we have to show that it is neither reflexive nor symmetric nor transitive. Okay, and here given is that a and b are from real numbers. Okay, now in this kind of problems where real numbers are involved, okay, and such condition is given, you have to check for every element. Okay, so here you have to take some specific numbers. Okay, so here in general you can't take it. Okay, you can't prove it in general, so you have to go for a specific reason. So for proving it is not reflexive, you have to take one element. Okay, if you take say a number which is from natural numbers, then this is possible, right? If you take 1 comma 1, here it is given less than or equal to. So equal to condition is fulfilled. Okay. If you take say a number which is rational, okay, if you take say 1 by 3, okay, what is the square of 1 by 3? It is 1 by 9, and this is in reciprocal, right? Denominator is greater than numerator, so obviously this number is less than this number. So this is not true for 1 by 3, and 1 by 3 belongs to set of real numbers. So this implies that 1 by 3 comma 1 by 3, this does not belongs to relation set. Okay, as this 1 by 3 is from real numbers. Okay. Next is for symmetry. Okay, for symmetry you can take natural number also. That is 1 is less than or equal to 2 square. Okay, which is 4. But 2 is not less than or equal to 1. This is not possible. Correct? So if you take 1 comma 2, belonging to set of this relation set, but 2 comma 1 does not belongs to relation set. Okay, you can show it here by proving the condition. Okay, so it is not symmetric. Next is transitivity. Okay, that is you have to take some element a comma b and b comma c. Okay, and if you take suppose 1 comma 2 and 2 comma 3, one way this is possible, that is 1 is less than or equal to 2 square and 2 is less than or equal to 3 square, correct? And here 1 is less than or equal to 3 square. This is also possible if you take some natural number. Okay, so I'll take another example now. For this numbers it is possible. So if I take this numbers, then it is not possible. See here, this will be 3 less than or equal to minus 2 square, which is 4, and minus 2 is less than or equal to 1. Okay, but 3 is not less than or equal to 1. Okay, so this 2 belongs to R, but 3 comma 1 does not belongs to R. Okay, so it is proved that this relation is not reflexive, not symmetric, and not transitive. Okay.